Okay. A year ago, I stood in Rotterdam in front of a group like you guys, and I was trying to convince everybody that Terraform programming is very easy. Does everybody know Terraform? Okay, amazing. So then what I'm going to tell you should be very familiar. You begin with the target API, but that you want to create your infrastructure in. In my case, it was typical Mashery. You have a very nice product from HashiCorp, and they have a standardized SDK, and what is left to write is a plugin in Golang. How hard can it be? Well, it pretty much depends on the complexity of the API that you're going to show, and in my fortunate case, because I'm working with enterprise and everything has to be super difficult, I have to create 5 levels of nesting until I can get to the thing that I actually need to do. This is kind of, that's what pays our bills. And I was telling to the group that I ran into one obvious problem, and that problem is mapping. It's enterprise, so there are a lot of elements, and it's kind of a lot of boilerplate. And there was one problem that I didn't tell to the group at the time that I was trying to build in Frankenstein. I'm Java developer, and kind of I learned Go kind of mainly to prove myself that architects still know how to code. And kind of, when I was looking at the whole thing, I'm just making a CRUD request. So everything in my head was saying, you know what? It should be repeatable. And kind of my background came up with structure like this until I started saying, you know what, guys? These are just all interfaces behind it. So kind of there's literally nothing in the way to stop me shooting myself in the foot by passing wrong data in and out. And it kept happening. So 6 months ago, when I was doing a major infrastructure upgrade, a moment has come to say, hey, I can right now make a use of my work. Except it didn't work because I have broken the code. As I was making it in my spare time, which pretty much you can figure out. You are on and off, you are forgetting what you're trying to do, you think it's a great idea, you didn't test it, maybe kind of you forget about the edge case, boom, production problem. And I decided, well, yeah, you know what? I need to go back and figure out, well, how to do generics and see if it's going to work. So guys, for those who don't know me, my name is Alex. I say that I'm everything architect. I can do all kind of projects. And essentially, what does it mean? It means that my full stack is reduced to essentially PowerPoint and Outlook. So if you're using mainly PowerPoint and Outlook, that you made it. Congratulations. And my talk today is Go generics or let go generics. And it's all going to be about trade-offs. And as an architect, well, architects never give you a straight answer, and I'm not going to give you either. And I will begin with the begin, because let's say generics go back to the beginning of times, to the times of Lisp. Does anybody know Lisp? Yes. Yeah, it started in the 60s. We're not going to talk about that. But then if you look at the timelines of major programming languages, if they're so useless, why people keep reinventing them? And one thing that stands out is the TypeScript, because Microsoft didn't just go create generics, they created the whole generic algebra out of it, which actually works very nice. Why do we do it? Because fundamentally there's nothing wrong with using interface. You want to prove? Silence. Do you want to prove? Yeah. Right. You use this programming language, well, maybe not as a programmer, but as a user, who will produce this. And you cannot remove, yeah? Which one it is? JavaScript. Exactly. It is JavaScript. JavaScript will never have, yes?
Who said it's fine?
Sorry?
Who said that it's fine? Who said that it's fine? It's totally fine, but
okay, so this is philosophical discussion. we can have it in the bar. Right. So JavaScript will never have generics, and we don't have a problem with it. So why bother? Okay, let's see why bother. Guys, can you get your phones and see if our small little quiz would do? Now is a tense moment. I don't know if it's going to work. All right? Is everybody ready?
Yes.
Okay. Now, Finding the mouse. Okay, let's see if we can get it here. Okay. It's like this. So the question to the group, have you written generic code before?
No. Impressive. What is Golang?
Yeah, that's a very good question. It's something which buys you very nice Chinese today. So keep coming. Okay, interesting. Next one. Are you currently using generics in your Golang code? Unbelievable!
Rockstar star programmers here.
Wow, okay. Do you guys want to come to the podium and talk about generics? Okay, amazing. Next one. Do you agree that non-generified code is, or generified code, simple to maintain, straightforward to understand, easy to test? What's your opinion? Aha, we're getting somewhere. Yeah. So we're using generics, but and life didn't change. Well, quite interesting. Quite interesting. So, like, you know, I think 2/3 think that no change, and 1/3 of the group thinks that it has become easier. All right. So, last one. What's holding you back on using generics?
There's no knowledge involved.
Are you guys done? So these are quite interesting results. So for me, it is a bit of a revelation to see that you guys are using it. It's great. And I want to offer my perspective to convince you not to. Because if you said that you're not using it, I would try to convince you to use it. Yeah, obviously, you know, this is the architect's, never a straight answer. So from my background, there are a lot which you can improve on using the interface, and mainly if you're coming from the Java background, where generics has been around for 10 years, we're just used to generified code, because generics are all over the place. And essentially, after years of being indoctrinated into using generics, you kind of stick to the workflow of your code, that you define the concrete type, you define common capabilities, and you write it. And fantastic. And it is fantastic. Any Java code, any Java project that is using any sort of REST API would write a piece of code like this at least once, and this is JSON marshalling or al-marshalling, and every project would contain it, and we do it automatically. So, kind of, you know, I can invent at any piece of my code a data structure, and I can just, you know, run it. Amazing. Until, as a Java developer, you start learning Go. And you said, okay, kind of, there is a standard al-marshal, that's all fine. I said, what about if I need to al-marshal too? No, okay, it still doesn't look very bad. What about 3? Okay, just I keep adding this stuff. What about 100? And that's the thing that occurred to me when I was doing the client library. I just realized that xdoclet would have been nice. Do you guys old enough like me to remember what xdoclet was?
No.
It was a Java code generation library which was thrown into the bin. But then even that would be better than manually typing. Another thing, and I'm showing to you kind of how Java developer would write a Golang code, and please make a good laugh of it. Because I'm proud, I'm an architect, I'm not supposed to be able to do this in the first place. Let's say I have a typed function, one of these that I showed you before. And you know, as Java developers, we're used to our factories or kind of common methods. What I realized, if I would just want to pass them in, I have to get the basic interface out, which leads to an interesting code like this, where you have to pass in a function and then you have to coerce the output of it to the type. It doesn't look very appetizing, right? Especially if you come from Java environment where you're used to all types polymorphism. Next to being an architect, I'm also a chapter lead in my company that I work for, and I periodically interview people. I do this for years. And from time to time, I would see people who say, well, I have Java and Golang experience, and I was asking them, what's missing? And that's what they tell me, generics, for years. Essentially, what they would say, well, if we don't have generics in our code, then we work for the compiler. We don't want to work for the compiler, we want the compiler to work for us. Which brings us to the whole philosophical discussion. What's the big deal with this third type of polymorphism, where you have to define these types, make it kind of super verbose, because it makes you go slower, literally. At the same time, an academic like me, like an architect, would say, yeah, but you know, we define abstractions. We would define common algorithms. And then if you would practitioner, you would tell to me, well, you know what, it's not gonna work. And I would thought, okay, how can I prove myself? Look, I'm gonna show you a very simple code that will prove to you that generics are useless in modeling even the simplest of the problems, right? Let's assume you have two cars, one Audi, one Tesla, and they can write. You're following, right? Okay, so you can run a simple unit test. You're with me so far, right? And then you say, okay, I have two cars. I want to right now start kind of car dealership. I want to model it. Okay, right. Looks like I need to invent the interface. So far, so good. I have a vehicle, and I can interchangeably pass back either Audi or Tesla, because that's what I'll care. This is very good pattern. This is strategy, etc. Until you come to the thing which is called refueling. All right, obviously Audi and Tesla take different fuels. How would you model it? As a number. Works very well, but what about if you have multiple types? Do you want to type safety? Yes, we can take in the interface, but then we have to write this ugly piece of code that verifies it. But then from the interface perspective, that's nice. And the thing is, the moment you start doing something like this, you keep inventing ways that can shoot yourself in the foot, because here, what I'm trying to do, I'm trying to put benzene 95 into my Tesla, but compiler doesn't know it because there's all interfaces. Until you run something like this, and you're hopefully you have a panic condition, will tell that you're terminally intelligent. It will happen in production, and after the nth element, your tech lead will come to you and say, "Hey, look, we need to stop because this is what generics actually do." You're with me so far, right? You start kind of introducing generics, okay, you can write them in a different way. And hey, look at that. You've written generics, now compiler tells you that, hey, something's not right here. So they have helped you to stop writing a crashing code. Now you're forced to write kind of electricity which goes in. Another benefit is that you cannot just pass something that will break consumers, because there is a type check. You can write a code that will consume everything. So, and Golang actually gives the generic type inference, so you don't have to repeat this verbose syntax. So it kind of collapses it automatically until you get a boring Java developer, like me, who asks you, all right, look, we have this interesting piece in the code. So I can take, let's say, vehicle, and I can swallow any generic, just any. Do you think we can do it? Everybody's asleep. I'm going to drop a mic. It cannot be generified. So now look at that. This was under 3 minutes. You have two cars. Can we assert the type of the fuel with generics? You just bloody cannot do it, and you go back to interfaces. So we have made a circle. Why did we actually start generifying in the first place? What would have worked with interfaces? Right. You know, I could have ended my talk right here. To say, well, kind of generics are useless. or kind of generic useful depending on what your output of the poll would be. However, there is one thing that generics actually are useful for in virtually all languages that I have been programming so far. And they are what I refer to associated generic types. Essentially, you need to have two elements. You need to have very big domain, a lot of entities, and you need to have repeated operations that chain each other. Let's say you do one, then it produces something, and then you do again another operation on the output of the previous one, etc., etc. I'm going to show it to you shortly. This actually has worked brilliantly in my problem because what actually I had all along in my architecture, I had a central element, which CRUD operation template that was just doing like that. Those are the basics. So I was able to introduce just 3 generic types. So the type for what I'm sending up and down, this is the update insert, identifier of the parent object, and identifier of the object that I'm actually creating. And now I'm able to formally define the CRUD operations. And now compiler can start helping me out. So what does it mean, the using associative types? Look at this. You can ignore the rest of the code because it's kind of error handling, kind of boring stuff. Let's say, first one, you have a Terraform state, and you want to figure out the identity of the object to read. So state to identity. Second one, you want to actually go to the target API and fetch the current values. So you exchange the identifier for the current values. And kind of the third state is you take the actual values and you put them back in a Terraform state so that Terraform can do its magic. So look, kind of if you have to create 40, 50, 60 of these kind of things, this is the example of associated types. You have identifier, parent identifier, and the update insert. And you start getting a help from the compiler. And actually, you know, when I was showing this method, it pretty much looked like your standard Golang code, except it gets very, very, very verbose when you try to declare something. And these things become quite annoying in typing. Yes. Next thing that can happen, a bloat can happen, if you will simply start ripping off interfaces and replacing these with generics, you will start telling the compiler to generate bigger binaries. Where would it come from? This is the kind of example that I have found in the very code that I have written, which I think is very good, just to illustrate the principle. What it tries to do, it tries to talk to the API and do a bit of error handling and marshalling. But look at this. There is point number 1, where I actually try to do something useful, and there is point number 2. Okay, when I initially wrote the code, I thought that it would be a smart idea to do a bit of a backoffs together. Well, anyway, kind of makes sense. And then finally, at the very end, kind of also handling 404 together. So we have 3 different concerns, which are right now cramped into one method. And if I will have 100 domain objects, this code will be copied into the binary 100 times, which obviously bloats the size of the binary without actually you realizing it. This is the hidden danger of refactoring pre-generic Go code bases. You actually have to keep an eye on it. Well, it's possible to do. It's not that difficult, actually, because it's kind of moving code here and there, but the message is it actually results in a much, much, much deeper refactoring that you can think. It's not just about put in a few times, you're done. Now, I know it's getting late, and kind of I didn't want to lecture you guys, so I want to add on kind of on a very nice bombshell so that we can go and have some exciting drinks. I want to give you 7 reasons to let go on generics. You ready? Yeah. So the first one is you like type and save code. Oh, obvious, you know, you can no restrictions, kind of, you're your own boss. You like rewriting things which are already rewritten, all right? Writing is rewriting, coding is recoding. Great stuff. Reason number 3 is that your tech lead has told you to clean up your code, and that's why you're not going to do it, like your mom, right? Another interesting element is that you've heard about functional programming, but you think it is a fad because it has to do something with generics, right? We don't do generics, then we don't need functional programming. How many of you guys are good with testing? Raise your hands. Yeah, okay. How many of you kind of want to improve it? Your testing? Oh, all right. So the reason why you want to pass on generics is that if you have generic code, you can write generic unit tests. Okay, fine. Next one, I like this particular one. The worse the code, the better the job security. You know, interfaces, spaghetti code, and then only you are the only one who can do debugging in the middle of the night. And last but not the least, there is something that generics will always be unable to do. Ask any Java developer, ask any architect, ask any Haskell developer. There are always a trade-offs. They're good for something, but they are never good for the problem that you may be facing. And perhaps the number 8 problem on the 7-number list. If you try doing this, your Go code will start stinking like Java, and this is exactly what we don't want to do. Probably that's very, very strong that you can do. Now, I understand that 7 reasons to pass on generics might be a little bit too hard to remember. So I decided that I want to reduce it to one statement. Have you guys played this wonderful game, Plants vs. Zombies? Yeah? Did you like it? So in the discussion about do we need generics or not, I have realized that zombies actually were right all the time. Because choosing between to use generics or do not use generics, always go for brains. On this note, guys, that's all I wanted to share with you. I'm happy to take questions.
Is binary bloat actually a problem in this day and age? Because my binaries are like a couple of megabytes and then add another megabyte. I don't care.
Exactly. This is a very good question. I personally have not noticed it. But then it obviously depends on what kind of thing you are programming. Like I'm programming administration/infrastructure management, where size of binary is irrelevant and performance is equally irrelevant. But I can imagine if you would try to write for example, AWS Lambda function that would be sensitive to the cold start, probably you want to squeeze it a bit further. So it's it always depends.
But even then, the cold start would be like minimal impact with generic.
Exactly. So depends on how. Look, depends on how you deploy it. Depends on how you provisioned. Depending how your solution is engineered. So there are many considerations that go into. So essentially what you're waiting, okay, what is more important for you? The reduced cognitive complexities when you look at the function and you can figure out, okay, I have rough idea what it should be taken and I have rough idea what it should be returning. Or you say, okay, I just want to remove all the impediments. I'm after the absolutely last bit of performance. Think what is more important for you, for the particular problem, for the particular project. Yeah.
Do you know if because we have generics now?
Yeah.
But things could change. Some
yeah.
Stuff could be added. I think there are some small changes. Now the latest release is some updates. But do you
yeah.
know if anything else is coming or being worked on in Go generics?
Actually, I was researching this topic. What is happening? I have not found any major updates on generics in the sources that I was able to find.
Yeah. Okay. So it's done.
Well, it is never done. I think at some point a few updates will be released, same as with Java and C. They all were receiving the updates, but let's say there are fundamental language constructions that cannot deliver the features, for example, that exist in C++ or exist in Java. And it will not be possible in Go, simply because the way the language is constructed.
I think there's now an active discussion on the topic of if you have a generic type, you want to access, if that's a struct, you want to access the members of that struct, which is currently not possible.
Yeah.
So if T here is some kind of struct with members, then and you have different struct with different members, you're not able to access them because that's just not allowed.
Yeah, okay.
Yeah.
But there's discussion on that now to allow that in some form and make generics even more useful.
The biggest change to generics that I'm aware of is the 0 that was proposed and accepted for 122. That will make instantiating an unknown generic.
I want to use it for long.
I do too. That's the only thing I want to use it for, really. It had big impacts and it came about because of the generic issue.
And wasn't there something about the binary bloat, the binary size bloat, that there was some kind of implementation detail about whether all these types for different T instantiations were going to be stenciled or created copies of all those types of functions, or if they're going to do some kind of smarter compiler code generation to not duplicate all those types.
Yeah, that's the whole thing about the compiler magic. So what Go specification says, the compiler might generate. Now, what is it might? So you need to decompile it and actually take a look what particular version of the particular compiler does. I have seen a few studies that people have actually tried to decompile into the assembly code and analyze the differences, what exactly is happening when you make a call on generified code versus non-generified code. And they figured out that in Golang there are extra lookups on generified code, which technically speaking makes it slower. But then, kind of, it depends on kind of what you find as an impact. Maybe in your case, you just couldn't care less.
Any last questions? Going once?
No?
Twice?
All right. All right. Guys, if you want to give the feedback, this is the algorithm. If you like it, reach out to me on LinkedIn. If you didn't like this talk, don't reach me on LinkedIn, reach me on Slack. On this note, we can close.